figure out if you did something wrong, okay? All right, so I did not assign the last two, so I went ahead and did them up here. So here's M. Now, M gives me two ordered pairs and assures me that it is exponential. So one strategy, this is what an exponential looks like. Here are my two ordered pairs. So one strategy is to plug both of those points in. Would you agree? Now, this is easy for me. This is not a word problem. They give me the two ordered pairs, so I just plug them in. Some of you were working in a context, and so you had to make sure you understood what your X and Y were as you pulled those numbers out of the problem. But I have them. So I solved both of these for A, set them equal to each other, cross multiply, divided, and cube root. Then I took my 2, plugged it back in right here, and figured out that my A had to be -3/4. So that's one strategy. Now, we know that geometric sequences are exponential. So another way I can do the problem is to think of these as a geometric sequence, where the second term is -3 and the fifth term is -24. Then I can say to myself, okay, what does it take? What do I have to multiply by to get from beginning to end? 8? And how many steps am I taking to make that happen? From 2 to 5 is 3. So R cubed in geometric sequence language is 8. So guess what? My ratio is 2. And then if I divide this by 2, oh, then I get my first term, and then I would have to figure out my equation. So what did I do to get my equation? Oh, I know what I did. Okay, if you did that, the first term would be -3/2. Agreed? So my equation would look like A sub n equals -3/2 times 2 to the x minus first. Now, I was told to write my equation in this form. So I have to recognize that this is 2 to the x and 2 to the -1st. Right? What's 2 to the -1st? 1/2. What's 1/2 times -3/2? -3/4. So it gets a little more complicated if you do it that way from a sequence standpoint, but it absolutely will work. All right, everybody okay? One way or the other? Okay. Then this last one, n, gives me an exponential. Now I was running out of room. I'm going to go ahead and erase this now. Sorry. I thought of that equation as -12e to the -t/3 plus 12. Does that make sense to you? Just put that plus 12 on the end. Okay? Well, it doesn't matter for the first question. The first question says how many milligrams after 2 hours. I just plugged in 2. And assuming I did it right, I got that, plugging in 2. It's the next one that was kind of getting me all messed up, because I have to use the graph of this to describe. So I need to know what this looks like. So what I did was change that right there into 1/e to the t/3 power. Does that move make sense to you? So that my exponent is positive. Then I recognized, forget everything else, what does this tell me about my equation? Decay. So I'm starting with this. But what does timesing it by -12 do? turn it into this, right? And then what does adding 12 do to it? Moves it up. So I have a shape that looks like this, but it moves up, and its asymptote is now 12. Use the graph of A, describe how the amount of medication is changing. What is happening to the amount of medication? Well, in the beginning, it rises pretty steeply, and then it starts leveling off, and it will never go above 12, which then answers the last question, what is the maximum dosage? 12, right? That's 12. Does anybody have a question about that?
Is the 1 over e just make negative t over 3 positive?
Yep. Remember, to make an exponent positive, you flip your base. So instead of the base being e over 1, it is 1 over e. And I need to do that, not for purposes of plugging in my calculator. My calculator will handle everything. I had to figure out what this looked like, and I need a positive base to figure out what that looks like, growth or decay, you know? So I need a positive exponent. So I rewrote it so that I can see it's going to be decay, flipped, moved up 12. Okay? All right, anybody else on those two? Okay, group 1. Let's take a problem from each group. Group 1, do you have A, B, C, or D that one of you feels confident coming up and talking about? Remember, the rest of the class has not looked at those problems yet. So you need to be thorough in your explanation. So, Xander, which one are you doing?
We'll just start it off with A.
All right, why don't we? Here's a nice marker.
Yep.
All right, so Xander's going to talk about problem A, and the rest of you should be working it, taking notes, or whatever. These are all review problems.
Alright, so we got 3 parts for letter A. It's pretty simple. So it says approximate the number of tigers in 2022. So it says that we start with 3,200 tigers worldwide in 2015, and there's an increase in the population by 40% over the next 7 years. And it doesn't say each year, it says over the total amount of time. So we're just gonna take, we're gonna find 40% of 3,200 and then just add them together. So if you do that, you just set it up. You can throw it into a calculator if you want. So 40 times. And you get 1,280. So you're gonna add 1,280 to 3,200, and that should come out to 4,480 tigers in 2022.
I love that, but I'm going to pause for just a moment. Can anyone think of another way we might have approached that? Multiply, instead of multiplying by 0.4 and adding, what if we just multiplied by 1.4?
Yeah, sure. That's possible.
That would show exponential growth, right? Okay, good. Go on. Good job, Sam.
Alright, so now part B says write an equation with a fractional exponent giving the tiger population for any year during the 7-year growth period, where Tn is the number of tigers and n is the number of years after 2015. So we know in 2015 that there was 3,200 tigers. So that would be the starting point, so that would be 0, some could say. So we know that it's going to be, I use Tn. So that would equal, the initial was 3,200, and then we know that it's 40% growth. So the growth percent would be 1.4. And then it says there's 7 years. So we know it's going to be, there's going to be a 7, but then if you want to choose like a year over that 7-year process, you have to, I mean, it depends what year you're given, so you throw in the n over 7. So that's how, that should be the equation for the fractional exponent equation.
Perfect, Sam. That's beautiful. Exactly right. Keep in mind that if he let n be 7, that exponent would be 1, and that would be 1.4 to the first, which is exactly what you want, right?
Yeah.
Perfect. Beautiful.
Alright, so now number C, we're going to use this equation to find the number of tigers in 2018, and we're going to round to the nearest whole number. So we're gonna use this equation, and instead of n, we're gonna throw in 3 because it's 3 years after 2015. So then you get this, and you just throw it into the calculator. And I came away with like 3,696 point something, but I rounded down to 3,696. So that should be your answer for 2018.
Nicely done, group one, perfect. I need somebody for group two to do E through H. One of two, okay, go. Who's going?
I go to whoever does the first question.
We're going to H. Here we go, problem H. You guys haven't looked at this yet.
I didn't work on
Okay, so H, we're finding the residual and interpreting it. So we're given the actual value when it's 27 degrees Celsius, which is 720.
I'll just start that.
And then we're given the model that's used to predict for it. So you plug in 27 for X into that equation. So and then once you plug that in, you get 6, and then you subtract the predicted value from here, and then this gives you your residual of 44.83. And so, when you interpret that residual, the model under predicted I think it's sales by $44.83.
Perfect. Anybody have a question about that? All right, group two, nice job. Okay. Group three, pick one from your group, I through L. Emily, which one you doing? I, here we go.
Okay, so we have defined what the equation for the half-life of RF265 was. And it has a half-life of 13 hours, so we knew it was going to be n divided by 13. And since it started with a 500 gram sample, the equation ended up being 500 times 1/2 and 13. And then for the second equation, it was the same thing, but we had to convert the days into hours. So it was 24D over 13 instead of N over 13.
Go ahead and write that second one down for us. Beautiful. Okay. Beautiful. Beautifully done, group one. Group three, I mean, awesome work. I want to just tack on something that's come up in some of our other problems. These are beautiful equations. However, do these equations tell me how much I am changing every day, let's say? No, they don't. So sometimes there's an additional question with these that says, find an alternative equation of the form a times b to the x, or find the percentage growth or decay. So let's look at our first equation. What was n, or h? H was hours, okay? Okay, so could I rewrite that equation as that? Would that be the same, oh, no, it isn't. Would that be the same thing? So if I go to my calculator and I type in 500 times 1/2 to the 1/13th power, or take the 13th root of it, I get, oh, no, I don't want 500 in there, I have 500. So I just type this in right here. That gives me 500 times 0.948 to the H. What does that 94.8 mean? Every hour, I am losing about 5.2% of my stuff. Would you agree with me? So just be ready to do that at some point. To take your half-life equation, which is beautiful, it's perfect, but sometimes you need to know what that per day or per hour is. All right, back to group one, good job. I need somebody besides Xander from group one to pick something besides A. So who's going?
I got it.
Joe, yes. Which one are you doing, Joe?
I'll do C.
C? Okay.
Probably the most challenging one in the packet. It's probably the most challenging one in the packet.
Thanks for stepping up to the plate, you know.
Hey, we need them here. We need 30 of that. So they want to find the half-life of phosphorus 32, and they give you an equation. And then so they want to find the half-life, and this is the initial number. So you want to plug back in a half of this, which is 87 and a half, to equal this is your equation, and then I divided by 175.5 equals 71.5. And then I just went into my calculator and did the 2y equals and did 0.5 and 1/32 t or x 71.5 like that, and then I found they intersected at 14.3 days.
Interesting strategy, Joe.
Yep.
But it's perfect. It's perfect. That's what it
Thank
was.
you.
I looked at this problem. I love it. I love it. I totally love it. But when I looked at it, I noticed coincidentally, there's a relationship between the number they gave me. What was is this my original equation? Yeah. Okay. There's a relationship between the number I want to end up with, which is a half, right? I want to have a half. So I rewrote 1/32 to the x over 71.5. I rewrote that as 1/2 to the 5 times x over 71.5. Because that's 1/32, right? And then I just divided 71.5 by 5, and guess what I got? 17.1, is that what you said? Or no, then it's 14. No, 14.3. Let me do my addition. Yeah, 14.3. I knew we met. Yeah. So does that make sense to you too? I love your strategy though. I love it. Perfect. Okay, good job. Alright, this row, somebody besides Drew needs to go up and do E, F, or G. Alright, here comes Drew.
By the way,
Which one are you doing? G? Who's doing G?
Don't mess it up for the whole group here.
Well, might be doing that
Alright,
right
let's go
now.
send
Yeah, man, ask.
Here you go.
Alright, I'm gonna do,
G.
so basically you're just writing an equation, the exponential equation for these insects. So you start with 53 aphids, so that's our first number. Our first number was A equals 53. And then this is your B, and so since they're increasing by 7/8 each time, or each kind of 2.5 days, it's gonna be 15/8 because it's 1 and 7/8. And then your exponent will be time, but since they only increase by 7/8 every 2.5 days, you put a 2.5 underneath the time, because that's how much it requires for them to increase by 7/8. Yep, that's it.
The only thing I would add to that is absolutely beautiful, Luke, but that A should be technically A of T.
We'll change that right now. Get that fixed.
And then it's absolutely perfect. Does anybody have a
It's actually perfect now.
question? Does anybody have a question for Luke? Does that make sense to everybody?
You have a question?
Good.
Got the like thing.
This is in group.
When everyone got it,
Okay.
from
Group 3,
Who's that? Were you dad?
somebody besides Emily, J, K, or L, here we go. Olivia, what are you doing?
J.
J, here we go, everybody pay attention. We have J.
So for J, they wanted us to find the equation of the graph, and it gives us 2 points. So it gave us -1, -81, and 1, -9. And just by looking at the shape of the graph, we knew that in the equation, the value here had to be negative and the value here had to be a fraction. So then we took the y values and we knew that because like the x value jumps 2 between these two values, because this is -1 and then this would be like that, it's divided by 3 each time to get to 9. So the value here would be 1/3, and then if you multiply -81 by 1/3, you get -27, and then it would be to the x.
Okay, one quick, I might have misunderstood you. Your X's are changing by how much?
Oh, is it by 9? Would it be 1/9?
No, your logic is fine, but your X's are changing,
They're being like divided.
your X's are changing by 2.
Yeah.
So I'm gonna be square rooting, and my Y's are changing by a factor of 9. So I'm square root, or 1/9. So I'm square rooting 1/9, so I get 1/3. I just wasn't sure about how you said you got your 1/3, but 1/3 is right.
Okay.
And it's to the X, and then it's times, what do you have out there in front?
-27.
-27, yeah. Does anybody have a question about that? I have one more question to ask you. How did you know from looking at the graph that your base was gonna be a fraction?
Because we knew it was flipped, and when you flip it back up, it was decay.
Perfect, beautiful. Everybody okay with that? All right, back to group 1, we're running out of things. Somebody has to do either D or D. Here comes Julia. Which one are you doing, Julia? B. Julia's doing B. Here we go, everybody pay attention. By the way, is Julia's problem very similar to the one that Olivia just did? Yeah, it just did this nice.
Okay, so B's pretty simple. You just go into your calculator and just stat edit and then put in your x values and your y values in the table. And then if you go to stat calc, you can see in the graph that it's an exponential, so we could go down to exponential regression. And then you get y equals 1.423 times 2.78 to the x.
That will work perfectly. Anybody have a question about that? Now, what would be another strategy? Think of what, Olivia did. How much are your x's changing by? 2? So we could square root, what is that number, 85? We could square root 85 divided by 11. And if you do that, if you square root 85 over 11, you will get her number. I forget what it was, 2.78. That's what you'll get, because that's what the calculator was doing behind the scenes. Beautiful, beautiful. Okay. All right. Let's see what we've done. Who's doing,
I don't
Well,
Really not the art of profit.
Y'all,
Oscar, thank you. Which one are you doing? E or F, Oscar?
what?
E or F?
I will be doing E.
E, great job.
Yeah, pick easy
Everybody
one.
pay attention.
Great choice.
This
pay
could
attention.
be
Let's
a
go, kid.
multiple choice question.
Aw.
Pay attention.
I'll wait.
I did
Oh, we're doing multiple choice questions.
Alright, should I just write each equation and then?
You can do whatever you want,
Alright.
however you thought about it.
So, I kinda went through, this is gonna might take a minute.
We'll wait.
So, starting with this one, I kind of chose the point, 1, 2, and so I was plugging in 1, and I had to get 2, so you plug in 1 right here, you don't get 2, you get a half, so that doesn't work. And then, we'll go down to the second one. So I'm looking for 2 again, because I'm gonna plug in 1 again, and you don't get 2, so that doesn't work. And then on this one, number 3. Alright, so I'm gonna plug in 1 again, and this time we're gonna get 2, because 4 times a half is 2. So 3's good. And then just a laughing stock of the class.
You're good,
Alright, so we're gonna plug in 1 again. 2. Alright, you're gonna get 2. Wait. Yeah. 2. There's 2. You're gonna get 1/4 times 8. That's 2, so that works. And then 5. Is that it? Yeah. Then that doesn't work. Plug in 1. And then 6. F of x equals 1/2. 2. Alright, then you're gonna get -1 and -1 to, or a half to the negative first power is that's 2, so that works. And then you plug in 1 again, you get 2. 4 divided by 2 is 2, so that works. And the last one. Get this guy. Alright. And then you plug in 1 and you get a half. Wait. Yeah, you get a half from this times -4. I think you get -2, so that doesn't work. So these work 3, 4, 6, 7. Right?
career will be, Oscar, I'll be a math teacher when you do it. That's beautiful, I do have a comment, and they've got that. How many points does it take to determine an exponential? 2. So, while 1 point will eliminate options, if the point 1 comma 2 is not on your graph, then it's out. So the way he threw those out was perfect. What might he have done though to be absolutely sure that he's got the right equations?
You could have chose
Took
0,
another
4 as
one
well.
off the graph, and maybe one could be 0, 4. Now, as it turns out, I did that and they all work, but you understand what I'm saying? You could have a curve that goes through 1 point that isn't the right curve. Does that make sense to everybody? Okay. When I originally did this problem, I love your method, Oscar, I love it. I wrote the equation of the curve and then figured out which versions of that equation were in the list. And that's how I did it. It worked out fine. Okay, week 3, can you guys do your problem in 3 minutes, 2 minutes?
Figure it out.
30 seconds. I love it. Which one are you doing in 30 seconds?
Probably on 5 on the
Okay.
clock right now.
All right, here she goes. She's doing a thing
Keep on.
in 30 seconds.
So Kay asked if a linear model was appropriate for the data of this regression plot, and we said no because the residuals indicate a quadratic formula instead of a linear one.
Well, it isn't, what the regression plot shows is a definite pattern. Would you agree with me? And so I don't even care what that pattern is. If there's a definite pattern, it is not an appropriate model. So I agree with you 100%. Your regression plot can show no pattern if your model is appropriate. Okay? All right. Let's get that homework in.